Okay, so in this question, we're asked about a gas undergoing an isothermal expansion. So let's draw it on the PV plot. Here's our isotherm. It's expanding, so it's going from A to B along something like this, and the change in temperature is 0 because it's isothermal. So the first part, we're asked, well, what's the change in internal energy? One of our equations for the change in internal energy is F over 2 nR delta T, which clearly shows us that if the temperature is not changing, then the change in internal energy is 0. We also know this because the internal energy is related to the kinetic energy of the molecules, and if the temperature isn't changing, then the kinetic energy of the molecules isn't changing. Okay, next we're asked about the entropy, the change in entropy. So we know for an isothermal process that the change in entropy is equal to Q over T. At present, we don't know what T is. We're not told that. We don't really know what Q is either, which is asked later. So let's come back and look at the entropy once we've worked out what happens with Q. Okay, we're asked for the work done on the gas. Okay, in this case, the gas is expanding. We know that the work done on the gas is equal to minus the integral of P dV. And in this case, because it's getting bigger, the change in volume is positive, P is positive, and so the work done is negative. Okay, so then we're asked about the heat transferred to the gas. So for this, we can use the change in internal energy is equal to Q plus W, but we already know that the change in internal energy is 0. So this tells us that if the work done is negative, then Q must be positive in order to compensate for this negative work done. So Q is positive. Which makes sense, we're transferring heat to expand this gas. Okay, so now we've worked out that Q is positive. T always has to be positive because the lowest temperature we can have is 0 kelvins. We can't have negative temperatures. So that tells us that delta S is positive. So now we've defined everything. The change in internal energy is 0. The change in entropy is positive. The work done on the gas is negative, and the heat transferred to the gas is positive.